Hi all, I'm Vijay Jethani. So today is our last session on Azure Integration Services. In this exam preparation session, from an exam requirement per se, let's see what we have to cover. First of all, we will look into the API management. In API management, basically we will cover why we require APIs at the first place. Then we will look into what components make up the API management. And we will also look into what are the different ways you can create the APIs, how you will import the APIs, similarly how we will configure the APIs or access to the APIs, and finally implementing the policies for those APIs. So that will be brief about our first section 1 of API management. Following on, we will look into the event-based solutions. Now in event-based solutions, we will basically cover event grid. We will start with the concepts. How do we access or even integrate an event grid in our solutions? Similarly, we will also look on the event hub, what it is meant for, and how do we configure them. So that briefly will cover our section 2. In section 3, we will cover the message-based solutions. Now here we will talk about basically two things. One is how the messages are stored in a Azure storage based queues versus something using an Azure Service Bus. So there we will look into how we actually create the topics, how we actually create the queues, and all those sort of message-based solutions. So that will be brief about what an exam blueprint looks like for our last session on Azure Integration Services, which is nothing but for our AZ204 exam. Okay, so let's get started. So at first place, when we talk about APIs, why do we need at first place? So from an API per se, they are required, or I would say a production use case for the APIs are, first of all, how do we actually modernize our legacy applications or assets, you can see. As you have been seeing from a legacy world, we have been tightly integrated of our apps with the backends as well as the databases. Now we want to make sure that everything is an individual entity and they are able to scale on their own. That is the reason we are looking for modernizing our legacy assets so that anything and everything, or I would say from a front end to a back end layer, everything is distinct and scalable in their own form. Okay, so that is what we meant by modernizing legacy assets with the help of APIs. Now, okay, if we modernize that, then what are the other things we have to take care of? So that is our second thing on API centric integrations. Now, as we have already divided them in modules, or in other words, we are now interacting with each other using APIs. So obviously they should have a standard pattern. How do we design them? How would we interact with them? That is what is meant by API centric app integration. So this will also help us. How do we get a read versus read write? And similarly, how we work around end-to-end solution with the help of APIs. Now, this was all from design aspects or what we want to get done with the APIs. But how that is actually getting converted to the users. From a user per se, I think they can come from any channel. Any channel means they can be on web, they can be on mobile, or they can be using any wearables or IoT devices. In short, what we are trying to say here is we are improving the experience of users with the help of this APIfication of our solutioning. Okay, and last is B2B integration. Is nothing but if I'm an organization and I have the partners working for me or a third party organizations, I'm trying to integrate with them for any business purpose. In that case, I need not give them complete access or even don't bring them into my own internal entities. I can leverage the APIs to only expose the functionality they need. That is the main by B2B integration. That means I have only exposed the relevant APIs which I, as per design, will need by my vendor or my partner. So that is what is meant by B2B integration. Okay, so I will just pause here for a while so that you can also look this through. In a diagrammatic form, this is how it will look like. At the center is all the APIification which I just talked about. There can be n number of data and services hosted in the data centers, public, private versus hybrid clouds, whichever you can think of. And at the end is we, the users, actually accessing these from a different use cases, or I would say a different form factors. Let it be an IoT, a web, a mobile apps from a user experience per se. Okay, so now let's dive deeper into API management, what it is all about. So with the help of API management, what we are trying to do here is, instead of exposing the APIs directly, we are bringing the gateway in between so that any APIs which we developed are first of all authenticated, then authorized with the help of policies so that only an authenticated user can get in. And also there are different use cases, like I want to restrict the different users base, or I want to distinguish the users based upon from which department they are. There can be n number of use cases where I want to categorize while they hit my gateway, depending upon which user, from which department the user is, they should be accordingly routed to a appropriate backend. So that is what the gateway will play a role of, not only routing appropriate backends, but it will also secure my access to the APIs. So at front end, it is us from a different form factors which we just talked about. We are coming through a gateway which is securing our APIs for the backend services which we are exposed in any shape and form. It can be containers, it can be our web services, it can be any event driven or even the databases. So you can think of anything at this point of time which will help us secure our APIs and bring a secure overall solutioning of our solution. Okay, so that is what we are doing here. We are securing our complete solution with the help of the gateway. Now, before we even reach there, what we need to have for us to actually configure that, that is where we come to a management plane. A management plane is where you will actually define in which shape and form those APIs are, how do we want to configure them, how we want to define them, and finally have some policies which we just talked about with the help of authentication, routing, and all those things. Similarly, SSL offloading. So all these things need to be configured in the management plane of API management gateway, you can say, or management API management in short. Okay, so here we are going to configure those. Similarly, once we are done with those configurations, I only want to expose the relevant APIs, which I will do with the developer portal, which is nothing but the user plane. And depending upon, as I said, which department and all those things, I can really have a access based mechanism for those developer portal as well. Okay, so these are the three components you can just think of from a API management as a solution. Again, I will pause here for a while so that you can look through these components before we move further. Okay, so moving on to the API gateway. This is how the actual flow will look like. We are here using any shape and form of the client apps. We are directly going to have hit the public URL of API gateway. Now this API gateway we have already configured with the help of policies which will define based on my request whether I should go to service A versus service B. For that we call it as a routing. Similarly, I will also configure, so to identify those users I need to have some authentication mechanism in place, also an authorization with the help of these identity providers. And at the end of the day, for this end-to-end security or a transit, you can say for HTTPS along with SSL, you have a SSL offloading taking place at the API gateway as well. And other things, obviously you need a logging as well as a response caching. That means if I want to respond back after the job is finished or after anything at this point of time, I want to cache at the gateway level, I can do that caching and finally send my response back to the client apps. Okay, so this is whole workflow, you can say, overall from an API gateway of the whole API management layer. So if you see what are we trying to do, we are going to accept API calls and route them to an appropriate backends. Similarly, we can also have the API keys and other credentials presented with the request. That means whatever I am presenting to the API gateway, it should understand that. That can help with the whatever policies I've configured for authentication and authorization. Similarly, I can also enforce a rate limits as well as the quotas. That means these many users can only access at a point of time or within those particular fraction of seconds or a minute that for this particular hits on that API gateway. Basically, what I'm trying to do here is I'm actually configuring my responses whether inbound versus outbound based upon the policies configured at this API gateway or API management layer. Cache response to improve response latency and minimize the load on backend services. Basically, if my backend services are not ready, obviously I can cache them for some time and then forward them when they are available. So that is configurable. Similarly, also response also, if you have, as you have see here, we can also cache the responses as well, not only the inbound, also the outbound as well. Okay, and at the end of the day we also have to store the logs and matrices so that we can monitor end-to-end transaction which are hitting our API gateway. Okay, so this was our first part of API management components. Now let's look at the second part, which is the management plane. As I said, this is a management plane. Obviously it will have a portal from where I can define and import the API. Similarly, I can also configure the APIs into the products and also set the policies, or I would say a configuration which will transform my incoming request based upon the criteria I have defined. Also, from a logging and monitoring per se, I can get the analytics from this management plane. And finally, obviously, I have to define the users who will be able to access not only the API gateways, but also from a developer per se, I have to expose only the APIs which my partners require, so that I am not bringing them to my backend or the internal network. And finally is the developer portal. Now, developer portal, as the name suggests, is for a developer to test the APIs which they are trying to integrate with the first party or third party. Say suppose I am the owner, so for me the partner is the third party. Similarly, for the third party or the partner, for them I think the internal whoever is exposing those APIs can be the third party. So that purely varies whether I'm talking about myself versus the partner. Okay, so in short, I am trying to integrate the partner with my websites which are hosted internally. So also remember, every call here is an API. So to protect them, I need to have an authentication mechanism, an authorization mechanism, or also you can say a key value or secret keys, so that if I expose them, I have a mechanism in place from where they can authenticate to the system. So we call them as a subscription keys or key value pairs, you can say. Okay, and apart from our own internal monitoring, we also need to have analytics on for the developers as well. Similarly, if they are working in an offline, so we can download those definitions as well. Also manage the keys for the products which are exposed or the APIs which are exposed to them. So coming back, what we have talked so far is these three components. Gateway, which is actually the heart, which is actually the performing the job for us. That means it is protecting our APIs which we have defined, so that whatever the user request hits the gateway first and they are routed appropriately to whichever backend services we are accessing. This is the first. Other thing is the management plane, which is nothing but again the portal from where we configure our APIs, import the APIs, define the APIs, and the developer portal is where we actually expose without even allowing them in our internal network. They are able to test the APIs which are exposed for them, so that they can test read write versus any functionality which we have exposed to those third party users or partners. So this is the bare minimum you need to know from API management components. Also in exam, basically they will test you on which specific services you configured based upon the components. Similarly, they will also test you on which kind of service you use for creating the policies around. Similarly, which type of policies you will use for what. So those all things they will test you on from an API management per se. And there will be obviously yes no kind of the questions as well, which will basically test you about your understanding on the API management or the messaging event solutions or even the message queue solutions. So if you know these concepts, I think should be good to clear those questions without any problem. But I think, as I said, this requires some time before you can even go through those questions. I think I would say get the concepts clear for these API or related message based solutions which we are talking in this particular section. Okay, so now let's move to the next part. How are you going to define the APIs? Now at first place, if you are just thinking about the REST APIs, just go blindly with the HTTP for defining those HTTP APIs, which are nothing but the REST based APIs. However, if you have thought about the GraphQL as your way, which is now the difference between the normal REST and the graph is GraphQL is more targeted towards single endpoint, and as the name suggests, this has again this already has a query language built in, so that it only fetches the information it needs, not the complete endpoint related information. So the difference between both of them, REST versus graph, is graph only brings what is required versus HTTP REST APIs, which brings the complete detail about that particular entity or object which we have defined. And there is no way to, unless and until we run some filters or we do some work on the REST APIs, we are not able to exactly bring only the required data or only the required key value pairs. But in GraphQL, being built on the graph query language, it has the capability to bring only the required key value pairs or the required information. Similarly, the other way to define APIs is gRPC, which is nothing but the remote procedure calls, and this is high performance uh, to define the APIs because this is a binary format. This cannot be intercepted. Hence, this is supported where mostly where you are sending your packets in a binary form and also within the internal network. At this point of time, you can't use them from a public to public communication because of the binary nature of this particular protocol. Okay, so you remember, first is for your REST APIs, second one is GraphQL, which is built on the REST, you can say, but then this has a query language built in, which is going to hit the single endpoint and have the appropriate data fetching. gRPC, you can consider this as a binary protocol or binary packet. Your data is transmitted in the form of a binary packet and highly secure. G stands for your Google. Okay, now this is the way of how you define the API. Other thing is how, based upon the configuration, that means if I'm using Open API or Swagger, I can use the JSON versus XML representation to define those REST APIs. However, if I want to have them in XML, REST APIs in XML form, then I can use the web application definition language for making the REST API representation in XML. And if I want to use the SOAP APIs, again I have a web services definition language. So SOAP is mainly related, or you will see the representation in XML for services, whereas the REST in most of the cases can have, with the help of Swagger especially, a REST as well as the JSON as well as the XML representation. And last you see the OData. So OData is nothing but your data sources, which can be your data stores, your databases, or any form of key value pairs. You can think of n number of data sources which you want to use as APIs, or I would say a fetch and write them using APIs. So OData is used for that. So in short, front three you can consider from an application per se, and the last OData you can consider more of a data base or data store related APIs which you want to access through this particular, or define them through the API layer. Okay. Now, while you are in your API management console, you can also have a source as well as sync mechanism for the services which you can directly integrate. Now in API management, you can have a logic app integrations for your workflows. Similarly, you have an app services which can either be a publisher or a subscriber as well for you to have integration with your API management. Function app can do some kind of logic or functioning or program, you can say, serverless function you can say for some kind of event driven logic. And finally, even if you container apps or serverless container, you can also integrate them with your API management. So this is how you can have out of box solution from an Azure per se. Okay, so again, from an exam per se, I think they will test you mainly on your understanding of the components which we just talked about, and also the role of the gateways versus the developer portal and all those things they can test you on. And finally, on the APIs, I think there will not be much on the code as such, but they can obviously test you on the different representation of those APIs, or which is best for REST versus SOAP and the OData. Those are things they can test you on. Okay, so with that, I think we can move on to the next topic, which is API gateway policies. Now, till now, first of all, we defined the components of an API management layer. Those were the gateways, then our management portal, and finally the developer portal. But internal configurations, or how do we control when something hits our front end, that is API gateway, how that is routed to an internal applications, or even what are our mechanism to route them, how do we group them. So those all things are taken care of with the help of policies. So that is what is written here. If we see why we need policies for an APIs, let's just go through them. First of all, we want to have appropriate behavior, so that any APIs they are configured from a publisher, and then how they are routed through the backend is what is written here. Then also we can have the response and request. First of all, whatever the request we are getting, in response to them in form of an APIs. Also, we have seen that we are applying policies between consumers as well as those managed apps. And finally, this can basically, whether it is for inbound versus an outbound responses, we can create policies for. So basically what we are trying to say here is, whether you are having an authentication authorization mechanism, whether you are offloading something, whether you're routing to your backends, similarly is your policies, whether I want a logic, the business logic at the inbound versus something at the outbound, is what this means. Okay. And these all documents are XML documents. You obviously will see an example of that while we do the labs, while we walk you through the labs. So you can see how those statements look like in an XML form. And then going further, I think we are dividing the configuration as a structured document. You will have inbound, backend, outbound, and error, so that we are very clear what and where we are actually putting the configurations in place, which will be nothing but an XML documentation for that particular policy. And also, if any error occurs and what exactly a logic you want to apply, I think you can also look into them from the policy configuration per se. Now this is how we create the policies, but we have to apply, or we have to be very specific. What are we looking at as specific scopes? Now scopes, basically, one is at the global level. That means it applies to anything and everything we have configured so far. You can say this, there's bare minimum, like I would say an authentication authorization should be applying to all. The SSL offloading should be applied to all. So obviously most of the time this will be a global rule. Similarly, if we want a communication between two different domains, so we call them as a cross origin resource sharing. So also the logging as well. So you can clearly see at the global level we can define these two. Now workspace is specific to the team who is working on a specific products. Now you can divide them by department, you can divide them by the application stacks or the technology stacks, and within the technology stack they might be working on some products, so you can obviously divide them at the product level. And finally, final one is an API, which is a single what request and response, or I would say a functionality which we want to define is at the API level. And once we define the functionality, obviously there will be some operation in form of a get, or I would say think about as simple as all REST operations. Let it be get versus put, post, whatever you can think of is an operation which we want to do on this particular functionality or this particular the application. Okay, so from caller to using an API management, then going to backend, the backend response to you, goes against to the outbound and backs to the caller. So this is how the flow look like for the API gateway policies. Again, I will pause here for a while so that you can look into this. Now below are just an example of whatever I have just talked through. We want to have some control flow. That means applying the conditions based upon how I get the request. Similarly, I am forwarding request to the backend services based upon some logic. I also want to limit the concurrency, that at one particular point of time, how many hits are allowed, or within the time frame, how many hits are allowed. I want to log the events in a specific format, is what here is written for the event log or event hub. How do I simulate the response, or even how do I send the response, is what the mock response means to. Retry is something I need to have an automated capability within, so that it retries after specific time before saying that I'm timeout, or uh, the relevant destination is not available for any reason. So these are a bare minimum you can think of, but if you really want to go through all the policies, then here is an article for that. This is very much detailed article where you have the all the policies configured or classified, I would say. This is a rate limiting and quotas. So here I'm just showing you one of the examples how this looks like. So these are the XML these are the XML snippets, you can say, how the configuration look like. Similarly, it will also provide you the attributes and whether they are required or no. You just have to go through them. Okay, so bare minimum, these are nothing but the configurations. Okay, so how we have in our is basically these are the different policies: rate limit, authentic policies for authentication and authorization. Then you have policy for content validation, routing, caching, transformation. Then these are the again different cross domain logging, GraphQL resolvers, policy control and flow relay. So they are basically classified the different policies within these buckets, and this is what the link I will share with you if you want to go through them. So in exam, basically they can give you a small snippet and ask you to fill that particular gap or the blank or maybe the drop down to just complete that particular policy. And remember, this is very easy. It's not that difficult. Just you have to know where they are being using, whether they are using this for inbound versus outbound, error and all whatever schema I have shown you before. Okay, so remember to go through these each of these links just so that you are comfortable knowing respective policies. I will also open up one on the authentication as well. So this is how this values look like, and as I said, the name, policies expression, whether it failed or not. And as I said, every XML document will have the sections inbound. Then you define what has to be in global, product, API and operation, whatever we have just seen through as a part of your scope. And finally, which version of the gateway are using. I think this is bare minimum to know that by default once we started it was classic and version 2 is the latest, and the other consumption base is something different. I would say the tiering, pricing tier, you can say, only when it is required this, but ideally this is version 2 is mostly you will use for your production scenarios. Consumption you will only use for your development or any of the testing environments. Self-hosted is more of at which is at your own on-premise. It is running in form of some container or the device at your own data centers. Okay, so these are the different types of gateways you have, but ideally for each of them you can actually see what attributes are required and just go through these sections. Okay, basically if you are working on HTML or XML, I think it should be very easy for you to navigate them through. But overall, just go through each and every policy groupings what they have, so that you at least know. Say suppose I give you to match a respective policy versus description, you should be able to do so. That can also be the kind of questions you can get in exam. Similarly, as we talked about authentication and authorization, we also talk about how do you validate the content. Similarly, how do you route those requests to the backend services. what are the caching mechanisms you can have, or what are the policies you can have on caching. How do you actually transform them? That means rewrite those requests. So those are the different policies you can go through. In interest of time, I think even though like we won't be able to cover each one of them, hence I have just given you an example for your reference, so that you can go through each and every snippet and just walk through the policy statements. Okay, so that is all we have for these policies. Let's move on to our next session. Now, how do we secure these APIs? Or what are the options available for me to secure these APIs? Now, I can secure the APIs first of all using subscriptions. Now, subscriptions are the ways like I do define for what it is required, and I expose this, or I would say I would give those key master keys or subscription keys to the developers or the partners who are going to access those APIs in a simple sense. Or other way is I can actually create a certificates for those particular clients or the partners who are going to access those APIs. So these are the two ways I can actually secure my APIs. Okay. Now let's look into what is there in hands-on labs for your API management. So while we will not have any hands-on labs in the exam, but if you go through this particular step-by-step article, then you should be very sure of what you have learned so far in concepts, and you are able to apply those concepts in practical. Now I will explain you an architecture diagram per se, so that at first place you are creating an app, a web app. Okay, so this web app will expose some APIs directly, and you as a user are directly calling them directly without any security in place. That means a man in middle can actually translate them, rewrite them, can do a number of things, because my APIs are not secure, or whatever the data which is hosted is not that secure. I can get all the data and can modulate and modify them in this particular request response transit. In this particular article, you will first have this app service create and try to hit these APIs directly. Then with the help of, then you create an API management gateway, or I would say a complete API management layer, where you will configure the policies along with inbound and outbound policies, and look through how actually now you are actually modifying your request and response using API gateway. Okay, so this complete article, right from creating of your app services, walks you through each and every step. How do you actually work out through APIs? How do you actually create the different services? And then how do you test them? That also is also given. And whatever you have seen, some of the screenshots of defining the APIs, adding the operations on top of that, you should be able to test and have hands-on with this particular lab. So I would suggest, even though this is not part of exam, you just go through them so that you understand what specific functionalities we are testing without having API gateway layer versus having the API gateway layer, and how do you configure them as well, obviously. And you will also be able to see the look and feel of the console and how the things look like in this particular API management. Okay, so there are also policies you are configuring end to end. So in short, you will at least have some hands-on on the API management, whatever you have learned so far in concepts. So with that, we have just completed our first section, which was on API management instances. We also have shown you the how do you actually create and import or document the APIs. You configure the access to the APIs either using subscription or certificates, and also shown you the different kind of policies you can apply for your API management layer. So that's all for the first section you can go through. So in short, how we started was given you brief about the components, right? Then a flow of API gateway, what each of the layers does, how do you define the APIs, how you configure them, what are the different services you are integrated with an API, and finally going through the policies and their configurations, and at what scope you can apply those particular policies. And finally, we just have completed the actual lab, what you do on this particular API management. So now let's move on to the next section, which is a event-based solution. Okay. So with event-based solution, at first place, what comes to our mind is at the center, you see the event grid. So this is nothing but the broker. That means I have some sources at left and I want to reach the destination, which is nothing but the event handlers. And in center, there is a broker which receive these events from the different sources which you see at the left. Okay. Now, as we said that this is an event broker, that means the messages can be coming from any services. We have to actually detect them based upon the logic of how that events need to be handled. So that is what you see at the right hand side, the event handlers. Whether I want to process them with the help of some code or function, or whether I want to pass them to some kind of a streaming event hubs, or some kind of the storing of those in the messages or storage queue, or even I want to integrate with them any other services which I know for sure will require or consume those events. So in short, everything here is an event. Okay, so something happened in any of these sources and I'm collecting those events, and based upon the logic at the event handlers, I'm actually processing or working on those events, right? So that is what is the bare minimum we have at the event grid. Now let's look at the terminology as well. Events, what happened, that's correct. Event sources, obviously where the event took place. Now topic is from a terminology per se, instead of having one-to-one, we can have one-to-many or one-to-one as well. But topics are mainly, I would say, they have a publisher. That means they always listen. The publishers are who actually sends the data, and subscribers are those who consume the data. So you can think about the topics where publishers publish or send the data and consumers consume or subscribe to that data. So this is the mechanism for sending and listening, right? Subscription, as the name suggests, allow you to define a logic of how these events will be handled. Okay. And finally, someone who is acting on these events have are called the event handlers. Now it can be just modulating or working on those code or having some workflow. It can be anything. As I said, ideally you in a normal world, either I would listening to those events and creating some dashboard out of it. I will be creating some logs or maybe storing the logs out of it, or working on the data itself. In a dynamic world, I will have those modulated in a shape and form so that I can have a dashboard or report out of that. So it can be anything. At the event handler, it is more of a consumption or a consumption engine, you can say, where actual logic of processing the data is being happening. Okay. Now before we move further, I think after terminologies, we also need to understand event schemas, something which is natively, or I would say a first party, that means Azure in this case, have the event grid schema for the something which functionality is already understood by the PaaS services. That means all of these services which you see from an Azure per se, they understand the event grid schema and are able to consume them in a shape and form, or I would say a configuration is very well understood by even the consumption layer which are on the Azure base. But overall, from an open API stack per se, I think what we should use is the cloud schema. That means irrespective of whether I'm using an open source event handler at this layer, similarly the source layer can be anything. I'm just using event grid as the event broker. I should be using the schema which is accepted worldwide, which is the cloud schema. So just for understanding, cloud event is an open source vendor neutral specification for defining the format of event data so that it can be sent and understood by a receiving layer, or I would say an event handler. Okay. Now last is event delivery. Now till here we were looking at the schema and the terminology, but what I can have, can I have a retry mechanism if my receiver is not ready? Yes, I can do so. Till how many or attempts I can do, that is a retry policy. And whether I want to send all of them in a batch, yes, I can do that, or versus because I want to conserve bandwidth as well. So I can send them in a batch. Say suppose I have a 64 KB events and I can group them in a 1 MB batch. That is what we do normally in this case. Okay. Similarly, if my receiver is not capable of handling the events, I can delay the delivery of by that particular seconds so that it is easily consumable by my receiving layer. Okay. And if say suppose after I would say a configurable period of time, normally you can say 7 days, or maybe even if you can consume for 1 day as well, but I think the maximum configurable period is 7 days. You can have them completely dead. That means they are actually then stored into some storage event that this particular event has failed as the receiver was not available to pick up those events. So that kind of the functionality you can have within the event delivery as a configuration. So in short, what we are trying to say here is we are configuring this broker so that it understands how these particular configurations are being pushed to the broker, and the broker understands that and forwards them based upon the configurations to a respective event handlers which are subscribed to those events and taking the actions, or the processing is done within these respective applications. Okay. Now a webhook is something like I have an endpoint which basically, instead of polling the source, I have just kept that endpoint so that it only listens for that particular event. I have configured them to listen for a specific event. Say suppose anything has gone down, that is an event failure. You can consider something has failed. So those are the respective failures. I want to trace them. So once that failure occurs, I need to take some action. Now this webhook will be exposed by the endpoint or the processing event handler or application who wants to actually listen to those events. So in short, what I'm trying to say here is the webhook will allow those events to reach to those consumers based upon when that happened, instead of continuously polling whether something has failed down, whether something has gone down or not responding. I have only configured that webhook which listens only for the failure events and then send those notifications to the consumer so that they can take appropriate action. So this is what is meant by the webhook. So we have the different connectors. Similarly, logic app is one of them, automation is one of them, functions is one of them, which can directly use the webhook as a events. Now the second part of this section is your event hub. Now event hubs are different than what we talked about. Now event grid was more of it connects your source to the destination or event handlers. There are some events which needs to be routed to appropriate subscribers. Okay, so this is as simple as connecting a different I would say discrete sources from the both sides. Okay, so you perform some events occur and you perform, but Event Hub is more of a streaming. Okay, like the events are being delivered. Like I would give an example. Say suppose you have an online food or you're delivering you want a delivery of the food item, okay, through website. You just go to the website and you order some food on that website. So based upon your location, there will be like you have the pin code, right? So based upon the location, a particular hotel will actually prepare the food for you and then delivered with the appropriate delivery agent which is available for that particular location. So that is whole particular scenario we want to look at. That means I'm ordering food online, and then I want to make sure that the online website send this order to respective hotels which are nearby to me, and then obviously deliver that to my home. So that is what the complete scenario. Okay, now in case of Event Hub, the event producer is a website which will send those events. That means the order is being processed online based upon where I live. The partition, you can consider them as the pin codes. Okay, so based upon the location, the partitions have been created within the event hubs. Now, as it understand that it is for the partition 1 and based upon the pin code, then it forwards to appropriate hotel, a group of hotels which you can consider them as a consumer group. Okay, so this consumer group actually prepared the food for me, and then with the help of the appropriate delivery agent, they actually send this food which I ordered online to my home. So here I'm receiving my food item which I ordered online. So you can consider this example end to end for understanding this Event Hub as a whole process. At end of the day, what we are trying to say is whatever events are being streamed, not only we are segregating them in appropriate, we are also running some or I would say subscribers are already being configured who can deliver the job for me or who can do the job for me, and finally delivering that particular event to that recipient. Okay, again here is a terminology which you can see through a hub climb. So in our case, I think if it was a website, then it becomes directly a website becomes client as well as producers. Similarly, consumer is someone who receives that. Party instances are meant for segregating where should I send this based upon the location or some configuration information we may have. And consumer group, I would say grouping of those similar kind of who in our case it was a hotels, but in other cases it can be different similar entities you can group together, and receivers will be obviously you or whoever at the consuming level who actually intend to receive that data. So those are the event receivers. And finally, obviously based upon the hits on your website, you can configure the different number of processing units. So that means I can actually make this high processing power by increasing the capacity. Okay, so that is what is meant by the throughput and processing units. So this I think basically covers your Event Hub, and then if you want to store something for logging or even running some analytics, this is an example of how the data can be also captured in a batch form and then stored in the blob storage or even the analytics data lake storage. So it's what's shown here. Now again, for this particular topic we have hands-on lab which I will show you, but I think just to summarize, on event-based solution we started with Event Grid. This is more of a connecting our source to our consumers. In short, terminology, what kind of the schemas we have available and how do we deliver them, or I would say how do we configure the broker. Finally, the webhook which will listen for those events and forward them for appropriate actions. Event Hub, I explain you with the help of an example. I have ordered food online and how that is being actually delivered to my home based upon where I live, which are nothing but the partitions you have to configure, and the hotels which will produce the food for me are consumer groups. So you can think from a different use cases as well. Okay. So let's now look at the lab which we have for Event Grid. Again, I will explain you. You create the topic. Okay. Now with this particular topic, what are we trying to do? We will have two respective. One is a publisher, another is your consumer or viewer. Okay. So we have the website, which is our consumer, which is viewing this particular events, right? And there is you can say virtual program which is sending these events to this particular event grid or event grid topic. Okay, so you are sending this, and then I have a subscription to this particular event grid which is consuming these events, and finally I am viewing these particular events on the website. So in short, I'm configuring my app services, I'm configuring my event grid topic, and I obviously have a publisher which is sending those events. So this is particular you will configure in this particular lab. So I will just walk you through how you're going to configure that. You're creating the event grid topic. Make sure you follow these screenshots and accordingly input the data as they have already, and make sure you are also creating these respective which are unique to you. Unique, that means you are able to have unique names publicly. Select appropriate plan, create a website. Okay, if you follow this step by step, I think they are very much doable, and even though it may take some time, but I think good for whatever you have learned so far in the theory. So the concepts are actually being validated while you do this practical. Okay, so remember, subscription here is more of a subscriber, not the subscription which we are talking about an Azure portal subscription. This is more of a publisher, and the subscriber is one who will actually consume those events. Okay, you also are having the webhook configuration, so you will learn obviously while you do these exercises step by step. Okay, so that ends our second section, which was on event based solutions. Okay, now let's move on to our last section, which is message based solutions. Now, as the name suggests, now previously in section 2 we were calling them as a events. Now here we see the message. What is the difference? Basically what we are trying to say here is, if you want to store anything like any particular from a message form, it can be a logs or something, or any particular I would say a notification kind of messages. So those all things you can have it here in a storage queue. Similarly, if you want to also have a limit on top of those messages, basically this is a simplest form of a queue. That means async functionality I want to implement. I have something happened, I want to store it in a, or maybe I want to connect two systems asynchronously which are not available at the same time or not available 24/7. You can think of all those use cases for the queues. Okay, you can have them 64 KB in size, and if you are configuring it for premium, I think maybe even MB or 100 MB you can go to that depending upon how you configure them. Okay, but a maximum size, I think it depends upon what storage you can have. This is 80 gigabytes of messages you can have in queue. Okay, so now as you see what we are using these messages, so if you are having any logs, basically as I said previously also, the events were more of something happened. Okay, something need to be tracked for failures or something, but here it is more of a static logs. or messages, there's a notification kind of things, which you want just stored in shape and form, which we are keeping in storage queue, is what we are saying here. Okay, now what is the difference between this storage queue versus service bus? Now this is more of a static. Okay, as you see, this is more of a storage base, which cannot have a more of a logic in it itself apart from storing them, or I would say an application is just built to have it stored somewhere like logs, which we can refer at some point of time, right? It is not equivalent to what events we had, right? So event, so just correlate the events with the message. Here we are just storing them in a some shape and form so that we can retrieve or look at that. It is not something for taking an action at this point of time. Okay, so it is more of a transmitting those messages. Now looking from a service bus. Now, as I said, from an same concept applies here as well. The only thing is whatever we were talking about events, now everything we talked here in form of a message. Now the difference between them is basically this is more of the way we call something goes in a queue and is transmitted to a respective consumer based upon. So this is now a message having a specific structure than event. Okay, so that is where you see service bus are part of a messaging infrastructure. Again, same publish subscriber, but now this is the message is not exactly the events. Okay, so they can be having a specific which can be used to communicate for a different communication protocols, or I would say a network environments. So this is just to communicate that this particular configuration or a message in a form which I want to be sent to a consumer. Okay, in short. Now when I want to use a service bus, so while it was being in the queue, storage queue, I think I was using it purposely for storing the messages in short. But when I don't want to poll my source, during that time I would have this publisher and subscription mechanism, which can be actually transmitting these messages from my source to destination. And as the name suggests, this is a queue, so obviously these are transmitted when your receiver is ready in a first in first out kind of a delivery model. Also I can remove the duplicates and all configurations we can have. As I was saying you, the application messages which you see here are 64 KB default and likely to go 100 MB based upon whether you are using standard versus premium tier. And this is a specific tiering example, or I would say a tiering Azure Service Bus tiering plan I have put through. Basic what you are trying to use, whether you are using queue, that obviously it's available in all, whether you want to use scheduled messages, it is again available now, but topics are only available for standard and premium. Similarly, if I want to use these messages for a specific sessions, I can use them in respective shape and form. If I want a geographically distributed or a DR, then obviously it was only available in premium. I want to have a Java messaging service support. Remember, again, I'm again saying messages are more of a some kind of information only, and events can be think of something has happened, some trigger, and then you want to take some action. Okay, so this is what is the difference between the events versus messages. A REST, from a configuration per se, you will think the topic whatever we define in the topic here can be same, but the purpose of actual configurations within that is different. One is trigger versus some action to be taken, one is using an information based messages to be transmitted from source to destination. Okay, so remember these things while you study these topics, because it will be quite confusing while you, if you are looking it for the first time. Okay, so going through service bus topics, you also can correlate different based upon the different filters. Now one is whether I want to transmit all or I want to transmit none. That is true filter versus false. That means all the message arriving, whether I want to pass them true versus I don't want to pass any of them to a subscription or anyone who's listening for those messages. The second one is the filter based upon the condition, whether I want to have or versus and condition. That means if my pin code is so, or I'm living at this particular location, then pass on this message kind of to this, pass on this message to me at that particular consumption layer or consumer. So that way you can apply that SQL. Correlation filter is something I want to say yes, I'm living at this pin code and this particular specific apartment I'm living. If both the conditions are true, then only I would have that final condition to be true. Okay, so depending upon how you are combining your logic, you have to select from this respective filters. And in exam, I think there will be short questions around whether, say suppose I want to have a priority of some orders, then obviously first of all I want to have the filter on orders, and then I want to see whether it is high priority, low priority. That is where I need an AND condition. So that is where I will apply the correlation filter. Similarly, if I want to have OR condition or AND or any particular specific filter, then it should go for then I should go for a SQL filter. Boolean is just yes or no. Okay, so this is more on the messages. Again, I'm specifying again and again, service bus is more on the message filters versus the event filters. Okay, now if I want to compare whatever we have been talked so far, this is how it look like. Compare the messaging service. If you are looking from an event grid, then in that case reactive programming, that means distribution events, I will use the event grid. React to the status changes, as I said, trigger versus actions. If I want to have streaming data, then obviously Event Hub is the service which I will select. If I want to just have a messaging, that means I am transmitting not events, I am transmitting the messages, then it has to be Service Bus Queue. Okay, so remember, I think what we have covered so far is, first of all, what exactly the queue is. Okay, a message queue which transmits a source message to a consumer with the help of broker, which is nothing but a queue here, a storage queue. In storage queue, it is nothing but the storage where I store the log or message and then I retrieve it using some programming logic. But in case of service bus, I have a similar functionality to whatever I had for a topic, event bus topic. Similarly, here I am actually connecting them using publish and subscribe methods. Publisher is a source and then subscriber is a consumer, which will have one-to-many or one-to-one depending upon how I configure them. Okay. Service bus tiers we have seen through, and finally the topic filters. And when to use which services, I have just given you whether it is event distribution, whether it is event streaming, or I'm just having a message pass from a publisher to a subscriber. That's it. So it can be very useful when I'm looking into the different systems. Events are mainly the trigger and the actions. Remember that way. I want to connect them, but obviously I need to have events or some kind of webhook listening for them before I can take action. But messages are more of our request response model. Okay, So the messages are more of a request response models, where I actually do some kind of a transaction and want to listen to my consumers whether they are available or not with the help of those service bus queues. Okay, but irrespective of whether I'm available 24/7 or not, I'm still able to complete my transaction based upon this queuing platform or Azure Service Bus. Okay, now let us look at the lab what we have for this particular Service Bus queue. I will share this link with you while I publish this session. Okay, so again the lab scenario. This is pretty much simple. You have a queue, a service bus queue, which is nothing but a messaging based broker. I publish something to it. It needs to be consumed by my reader or consumer. It's simple. Obviously, I would have two programs. One will publish, one will listen, and this is a processing engine which will actually based upon whatever delivery mechanism I have will be delivered to from a publisher to a subscriber. So in short, you will just obviously create this service bus and then appropriate the pricing tier you have to select, then how you will actually programmatically embed the keys is shown here. So you need obviously the ID for that, so that you can also create the appropriate console application. One is acting as a publisher, another is acting as a consumer, and then finally you have your complete system connected together, which will transmit the messages and one will receive the messages. Okay, so finally you will have the dashboard as well. So as I said, you will not have any particular hands-on lab in exam, but make sure you try this out so that whatever concepts we have covered, you are able to demonstrate and using this particular concepts in this session, you are able to apply them in exam. Okay, so to summarize, in this particular last session for our AZ204 exam, we have covered API management, why we need APIs at first place, how do we configure the APIs, how we configure the access to the APIs, and also look how do we actually have different policies, whether they are for authentication versus late limiting versus any particular transformation job which we want to do on APIs. Then we looked into the event-based solution, which is nothing but the trigger and the actions based upon what happened at the source and what action we need to take at the receiver end. And messages are more of an information. It can be log, it can be anything around the how you actually match the non-availability of your consumer, or I would say someone which is at 24/7 available versus someone is only available for some time. So you can asynchronously pass the messages based upon the availability of your consumer. Similarly, you can also have a logging mechanism for those messages as well using the service bus queue. Okay, so just go through the labs as well so that you understand end to end. So that's all for today's session. Thanks for listening to the session.